Hello and welcome to CodeChef General Challenge. Today is very short video. I believe it's like a part of CodeChef Long General Challenge this year. Um, I was solving it like in the background while doing other videos. I did not do all that well. I solved like three and a half problems in Division 1. So ended with rank 69. Congratulations, pretty cool rank, much better than rating, but whatever. Uh, so I just found out that CodeChef does official editorials. Let me show you. So they have a YouTube channel, and you can find the you can't no you can find the link like here, right? So if you head on to contest page, then you can find the link, right? So I decided like, Upsolving is very important thing in competitive programming. Whenever I don't solve the problem at the contest, I definitely try to solve it later so that I can actually learn something that I didn't know, which led to me not solving that problem in the real contest, right? So upsolving is pretty damn important and you better do it. Like, absolutely. Yeah, just kidding. If you got no time later, I mean, it's perfectly fine not to upsolve like every problem. But like upsolving at least one problem from contest is very good practice. So I found out this editorial, so to say. Now, excuse me for not knowing how to pronounce these names, but here we have like a guy who's an editorialist, and I must say he's pretty damn good. So here we have his page on CodeChef. He has 5 stars, so the same amount of stars as I have, right? Pretty good, must be pretty good. And also we have his CodeForces profile, which is, specialists, not all that bad, right? These two graphs align perfectly for me, right? You take your rating on CodeChef, you subtract something like 500, you get your rating on CodeForces. Pretty reasonable, right? Except for now, like actually I'm yellow here and I'm yellow here, but whatever, never mind. Maybe he's just putting much more effort in CodeChef. Maybe he's familiar with like all little platform dependent things. So yeah, it's perfectly fine if you're like good at one platform and not all that good in the other platform. So it's okay. Now, this thing I wanted to discuss, like here we have pretty involved solution of a problem and or game, which includes a fast Walsh-Hadamard transform. So FWHT is some sort of smart operation, right? With sets of binary masks, something like that. So a pretty smart thing, like I don't know it, honestly, I don't know it, like it's the first time I ever hear about it. Actually, it's probably the second time I hear about it, but this idea never came to my mind during the contest. So, however, like this is all good, this is all good, this is all good. And now I just don't understand like people. Back here, we had a pretty involved thing that I don't know. And I mean, like, I'm bad, right? I obviously don't know a lot of things, so it's perfectly fine if you know something that I don't know, right? He uses mem set size up. It's subjective. I'm not going to comment on it. But here on lines 59 to 61, guess what happens? He has a maximum value of all the input numbers. And this loop computes the logarithm of max value. So a person knows like pretty involved transform, but apparently does not know that you can compute a transform like a logarithm of a number by writing something like 31 minus built-in underscore count leading zeros of max, right? So this is like one line, and it's also like 15, it's shorter, it's just shorter. And also you're like, it's never gonna let you down. You know? Like here, for example, you make one extra increment of bit, which you will have to subtract later. But here you get answer straight away. So here you have to like understand what you're doing. Here you just type in built-in macro. And this macro will be, of course, in C++20 included in a header bit. So yeah, obviously, it's just strange to not know how to compute a logarithm quickly. This is first thing that I wanted to tell. It's perfectly fine to compute logarithm like this. You don't necessarily have to use mechanical optimization, so to speak, a sort of hardware things, right? Because it's not yet in the standard, so it may be like implementation dependent, although it's not because it's like used for the last 30 years. Potentially I'm wrong and it's like 20 years, but it does not really matter. But another thing that bothers me is like in problem constraints, we actually know the exact value of that log. It's 20. All numbers are no greater than 2 to the 20, right? So you're gonna, what are we talking? What are we doing here? You know there will be max tests when the max will have 20 bits, right? So why bother computing logarithm by hand when you can first compute it like with some library function call, and second, you are given it in the problem statement. I don't know. If you know, tell me. I would like to find out what's the purpose of this. And also, like, not only for you to understand, like, not only, let me grab my drawing thing again. To compute this logarithm, we not only need this loop, which continues a bit below when we subtract another one from b, but also we have to do this, this, and this. So we have to like explicitly compute max value, knowing, like perfectly knowing that the only purpose of this max value in this program is to compute how many bits we have, okay? And we know this from the problem statement. So later he just says like bit is equal minimum of bit plus 1 and 20. And I just don't understand. Like I'm pretty damn sure that he can write just 20 and he'll be fine. Like see, mx is not used anywhere else in the program. What's the purpose of this variable? You can get rid of it. You can simplify your logarithm computation instead of, I don't know how many lines. Also, for whatever reason, he sets this to 1. I'm not going to question it. I did not implement the solution yet, so I may be terribly wrong about it. Also, like, interesting thing. He said he proves, excuse me, in the editorial before, he proves that we will need at most 20 operations. And you can clearly see that in this loop, we do 21 operation. And people don't usually type like less equals, right? People usually type from 0 to at most, like less than 20, right? So there must be some reason to it. I'm assuming it's either one of the two. Either this is completely unnecessary and therefore I don't understand how it ended up being in the code, and because this is not what you typically type. Or like this is necessary for to get accepted, right? So therefore his previous proof of exactly 20, like at most 20 operations is wrong, because here we clearly make 21 operation, right? But maybe I just know nothing about formal proofs, and here we have like completely fine formal proof, although it's terribly structured. You know, you don't necessarily have to prove things in competitive programming. Sometimes you just have very, very good intuition about how to solve a problem, and it just works, right? And it just works fine. Uh, Often in real life, you'll find with like pretty good heuristical algorithm, right? Heuristic-driven algorithms. You don't have to prove things like formally every day. You know, potentially it's just my sort of mathematical background kicks in, because you may not know, but if you take a look, like I have a T-shirt which reads European Girls Mathematical Olympiad, and it's red, and it basically means that I was grading papers for international competition in mathematics. So I know something about formal proofs, and this proof does not meet any criterions of formality, but it's totally fine in compatible programming. You just don't prove things, you just solve problems, right? No, no, that's not what I want you guys. That's not what I want to teach you, right? I'm trying here to like prove my every solution for every problem that we solve here together, because it's important. Like every time you prove something formally, you improve your understanding of concepts. You will get better at these concepts. You will be able to solve more problems related for these concepts. This is what our goal is, for you to learn new things, for me to learn, because I'm learning with you guys. No, like I did not know about a fast a Walsh Adamar transform, whatever that means. I will certainly read about it. It's a huge sense for editorialists, for teaching me something that I don't know. So I decided like I also gave you some sort of commentary about this editorial, what I find useful, what I don't find useful, and I don't want you to write these cards. Okay? Uh, I'm assuming that his code for whatever transform we had here, like binary convolution, something like that, is good, because like there's only one way to implement it. But just other parts of the code are strange. So yeah, anyways, this video is not about like who is a good editorialist, who is a bad editorialist. I'm a terrible editorialist. Like I write terrible editorials, so, and also I usually write terrible code when no one's watching, right? So maybe his was just writing to get accepted and did not care about showcasing it later. And then the coach chef team just said like, hey, You submitted this theme. Can you please make an editorial? And he was like, oh shit, I did not think about it. Now I have to make an editorial. Like, yeah, whatever. I will just like explain intuition behind the solution. It's perfectly fine. I'm very happy to see these editorials published in the form of the video, right? So, uh, I can't remember such thing like a year ago when I was also participating in some other concept competitions. So yeah, main topic of this video is upselling is cool. You should definitely do it. That's it for today. Thanks for watching. Bye.